So we're going to start off here and by looking at the channels themselves. And channels here are really, you can think about them as a way to kind of hold your data, but they also link together different processes. And it's this connection between processes via channels, which drives the execution. And this is where the kind of reactive programming model comes from in Nextflow, where the kind of flow comes from. Because as soon as an output leaves, say, task A in this case, it basically becomes available for task B to fire off. And that linking between them is really driving the execution here. And you also have this ability to have those channels contain different kinds of elements. We've seen examples where we had a single value, like a sample ID. We also saw examples where you had a single file. And we also had examples where we had like tuples, so they had more complex data structures. Those channels can contain anything. They can contain, maps or dictionaries, and you can contain all sorts of other things. And this allows us to be quite flexible in terms of the way that we write the pipeline. So this is going to be a little bit more theory than we saw yesterday, but hopefully we can start to kind of build on this, and it will be sort of important as you build it up. The first thing to consider is the actual channel types themselves. For the most part, we're going to be talking about queue channels. These are the normal Dataflow channels, but it's important to be aware that there's also a value channel. A value channel is just a channel with one element in it, so essentially no other elements. And it has a slightly specific meaning in terms of Dataflow programming, so the difference between these two. And we can dive in to see kind of what's happening underneath Nextflow to see that. In terms of what they are, the queue channels are asynchronous. So, I mean, they're non-blocking. It's kind of where the parallelization comes from. They're unidirectional. So you think about process one going to process two, it's really going in that direction. You can't send the same channel, back up that way. And they're first in and first out. So as something enters that channel, an element enters that channel, you can be guaranteed that it's going to be delivered there the next time. So we've got a couple of ways, and we've seen this basic example of how we can create a channel. And we say, have a kind of assignment of the channel name here. So the channel equals this channel from 1, 2, and 3. In our case here, now we describe this as a channel which contains 3 elements, and each of those elements is an integer in this case. So if we take a snippet of this and have a look at what it looks like here, if we paste this inside here, there's 2 different things that are taking place. The first is that we're actually doing a print line statement on this, which is actually something like a groovy function. And then we're also doing a view, which is a Nextflow function. Essentially, we're viewing the contents of those channels. So this is going to create slightly different outputs for us. So I'm just going to save this as my channels.nf and launch this. And the point of this is kind of really more for demonstration. But if I run this Nextflow run channels, I want you to look at what happens at the output here. So as this launches through, you can see that we've got 2 quite different outputs. And this is kind of going into what's happening behind the scenes for Nextflow. The channel here, in this case, is actually what's called a Dataflow queue object. And the way Nextflow works in this is that queue contains 3 elements, which is what we call, those elements are Dataflow variables. This is value 1, 2, and 3. And the interesting thing here is that the final one, it contains a poison pill. This is basically like a stop statement. Why is this important? So the way that the Dataflow programming model works, imagine you've got your pipeline and you say, okay, run this against all of my FastQ files. This is fine because you can imagine the first one's there. Okay, it enters the queue, runs that next process. Okay, the next one runs, and maybe 10 run in parallel. But how does Nextflow know? How does the process know when there's no more? How does it know when we've finished the execution of that? Well, the poison pill is what drives this. The poison pill essentially says, hey, stop, like we've reached the end of this. The queue is now empty, and you can say that process is complete. And that's kind of the way that Nextflow is able to tell. Now, obviously, you don't need to use this when you're actually writing Nextflow. This is just kind of more of a kind of theoretical aspect of it, but it kind of shows how it works. What we often are doing, though, is actually just viewing the contents of the channel. So this is the kind of more typical thing that you'll be doing as you're debugging, as you're writing the pipeline. And it's also important to point out, this here is on 3 different lines. So see 1, 2, and 3. This means that they are different elements in there. This is not a list, for example. It's not like we're creating here a list where we're saying run like this, in which case you would have the description here, You can say, actually, in this case, they're from here, but you could say from list and you would put them in things. So you have to be careful about the way you construct your channel, because you can be in situations where sometimes you want to put those things together, sometimes you want to split them apart. And in doing so, it kind of makes a difference to the way Nextflow works. The other area that we saw yesterday that can come up is when I take that same channel, I want to view it twice. And this is where we saw yesterday around the having to rename those channels. So if I take this and I paste it in, we end up in a situation where we're calling that channel twice, where the elements of those channels are being essentially being used twice, and then we can't use it this way. So we have to do the separation. So the difference between kind of queue channels and value channels is that you can kind of get around these problems, because the value channel itself doesn't contain this poison pill, and therefore it doesn't end up in the situation where this is taking place. A little bit technical, don't worry if you go into the details of that. The way you can create value channels is, because it's a single value, it's very simple. You just say channel value and you put that in there. You can print that as many times as you want. And then when you have the value channel, you can use these different operators as well. Okay, let's jump into the actual channel factories. And I think it's important to point out here all of the docs for this, because we can't cover everything in this workshop. But more importantly, it's to know where to find the information when you want to. So we are looking today in starting off in channels, and we are looking here in the channel factories. And here's the different channel factories that are available. We're going to see a few of these and kind of go through from there as well. So the basic one is a channel factory with the value channel. Here you can see that this is an empty channel. We're creating one here, which is just a single string. So that channel contains a single string. And here you can see that it's actually a list. And this is the point I was trying to make before, that when you have that, this is not a channel which has got 5 elements into it. It's a channel with a list, and that list is made up of 5 items. So it's slightly different in terms of the execution. Now, why does that matter? Well, imagine if I had something downstream from this. Imagine that I wanted to use, the typo here, actually, this should be 3. Imagine that if I had a process, right, and I said, my process is food, and I want to say, as my input to this process, I wanted to specify I have some value X from some channel 3. Now in this setup here, I'm just going to create a very basic script, which is going to type this in, which is going to print this to screen. So let's say we do this. Here I'm just going to say print X, print $X in this case. Okay. What I'm going to do for these exercises, I'm also going to show you a way that you can print everything to screen. Now, typically you don't want this. If you've got tens of thousands of tasks, it's not great to print stuff to the screen. But we can also do something what we call process.echo. This is a directive now. And if we say here, this basically means it's going to print this to the screen for us. Another way of writing this is in here, you can say echo is true. And we saw this a little bit yesterday with those directives. Why am I showing this? So let's save that and just run here. I want to show you what happens when we run through this. So here, we're going to see, actually, this should be an echo command. Go there. The launching of this should result now in a single process. The reason is this is a value channel. If we say in here from, let's say, and then this one here was not a list, but a single element, then we can get 5, basically food runs 5 times, so 5 tasks of that. And this is something sort of important to note for how you do that. Here you can see this process.echo is printing it to the screen for me. And you can see that those elements those processes are kind of running in parallel there. So you can get 2 and 1, 3 and 4 and 5, etc. Okay, so that's kind of basics differences with value channels. You'll often see value channels for like a single file, maybe from there, or a single element. It has some basic use cases, but most of the time in kind of the data flow aspect, we're going to be talking about it with the queue channels. And this is where all of the rest of these are coming from. So these are all queue channels. So you've got channel from, which is here is just the most basic usage of that. And then you have, in this case, you can just print these to the screen. And then if you see the new method that we've developed, which is it's an iteration of channel of, and this allows you it has just some better behavior in terms of lists. So here you can create a channel of, and you can say, okay, 1 to 23, and then I also want X and Y. And this kind of creates for us all of that we need. So save that and close that. And there was some kind of inconsistent behavior, which I kind of showed you before in terms of the lists and how that works. So this will now create, we would describe this as we've created a channel, and that channel itself contains 25 elements. Each of those is an integer, and then X and Y as well. Okay, if we think about other aspects or other things that we can contain here, we're often in a situation where we're not dealing specifically with values, but we're dealing with files. And files are particularly important when we want to run in a distributed environment. When we're running locally on our machine, like this, if I'm just running here and I say Nextflow run here, Nextflow can access all of the files that are on this machine when I'm running. But as soon as I start to go run in a distributed environment, maybe on your cluster with a shared file system, particularly in the cloud with like object storage that has to be transferred, the use of files becomes really important. And therefore, we need to have a special way of handling files with Nextflow. But we also want to do this in a way which is portable. And we don't want to be the one saying, okay, my input here is in S3, so be careful about that, copy that over there. The way that we do that is with these, basically a factory method for creating files themselves. And we have this way of describing this with a path. So we can say a channel from path. And what this creates now, instead of creating like a string, instead of this being like a string that we've created, we actually create a file object. And that file object can be manipulated and used in specific ways. So let's take the example here and see what this looks like. We have some data inside of here. So if you want to try along, you can see in here. I'm just going to show you, if I go in here, if I go ls on my data, here I have some metadata, and you can see that I've just got some different files, some different patient data here, and different things, and different CSV files. If I was to create a channel and I wanted those to be as input, I could select here, I'd say, okay, channel from path, specify the location. In this case, I want all my CSV files, which in this case is patient 1, patient 2. And then I want to say view them in this case. And if I say to a view on this to see what's the contents of this, when I run this, you'll see that I mentioned here, which was in this case, I gave it a relative path. So I gave it this path of data matter, but it turned it into the full path. And the full path will become essential here, because if I say I was running in a shared system, it's going to need to be able to symbolically link, and it needs to symbolically link the full path, not the relative path in that regard. Okay, so that's the kind of basics of dealing with files. We also saw that in these channel factories, we have different ways of building them. So we can build them not just from the kind of basic default way, which is where I'm providing the single argument. That single argument is how I want to build that. But we can just determine the different types of files that we want to add in here. So we have all of the options for saying, for example, I want to say the type. Maybe I wanted that to include, for example, just directories. I'm only searching for directories. Or maybe I wanted to have a hidden file. So if we say hidden is true here, I'm going to save that. And what I'm going to do is I'm just going to make a hidden file inside data. So let's go inside data and meta. And let's imagine that we had a file called x.csv. So I put the dot there because it makes it a hidden file. And when I do this now, you can see that we're going to run the first time with hidden is true. And it's going to find that file. So we're going to have an channel with 3 elements. You can see this new file is included in there. If I was to remove this, that would save that there. Okay, let's jump into our first exercise. Then we can see that one's run through. What I want you to do is to be able to see if you can create a channel using from path, so the one here. And I want you to find the FASTQ files that we used. And then I want you to do that also to add the search for hidden files as well. And then we want to print them to the name. So if you remember, you have some chicken samples, some chicken read samples in our data file. So if you go data gggal, you'll be able to see those there. And I want you to try and create a channel just with the files. And I want you to do them as individual files now, not pairing them like we did in the exercise. Okay, hopefully I've managed that one there in terms of running that. What we need to do here was just to replace, to really write channel from path. And here we're going to put in the directory that we had. You can even just write this as data, and here we're going to put in star.fq. And when we run this here, at least in the first example, we can run that through and hopefully we'll find our files. So we should have 6 different files. So describe this as we've created a channel with 6 elements. Each element is a file there. And we may want to add in here hidden is true to be able to do that for the exercise as well. The way that it works is it enables you to do kind of glob expansion, which is a typical thing you'll see. So if you wanted to do, for example, okay, look for FastQ, but also look for FastQ like this, for example, you can do this, which will expand that out, and you can start to search for kind of more complex objects as well as you do that. You can obviously turn it into however descriptive that you want to go. You often see things like this. This is like searching for a single like directory, so it's only going inside this directory here, but you can also cross directory boundaries with this, kind of go deeper for that, and a whole bunch of other options for setting that up. Most of the cases that we typically see when you're doing this with, say, for example, read data is using from file pairs, which is a different of the channel factories that we have here. So channel from file pairs. The syntax here is very similar in terms of what we're searching for. But now we can describe for it that we want to find specific files that we want to have some kind of pattern to match between 1 and 2. So we might want to say, show me all of the files here. And then the idea is here that you can put in the 2 pairs that you're trying to find as well. So in our case, you may want to search for them _1 and _2, and we can place that there. If you want to, sorry, just to show you exactly what we're doing with that, _1, _2. Another thing that's interesting around the from file pairs one is the other kind of ways that you can set this up and how this links in with our processes. And the reason this is important, imagine that we had a process here and we said, let's say our process was doing like FastQC. Inside here, we want to specify an input. We want to use as input our thing that we've just created, the channel that we've just created. Now, this is where it can get a little bit interesting. So we should match whatever this is created, because we're going to say something from, let's just give this a name. So there's another way to do this, like our set. Let's call this our reads channel. Okay. Now we want to use this as an input here. So from reads channel, what we have to put here is dependent on the structure of this. And if we look below, the structure is a tuple made up of a value and some files. So here we would write, in this case, tuple made up of some value that we're going to assign. So some value like sample ID, we can just assign this on the fly. And then the second one is made up of some files. So you could say like a path of my reads from here. And this is the basic kind of construction from this. We'll see this a bit later on. The important point, though, is if I say here, if I've got a script section, which is just going to echo the output, just echo the contents of those reads or echo the sample ID in this case, it's enough for us. Imagine that I had this set up here and I had this process here. So this takes a tuple, which matches this. So in the first case, this should work. And it should run through here. And we should get this matching, and we get FastQC, which runs 3 times, and we're just echoing the sample each time. Now, the other thing that we could do here was we could change what the contents of that channel is, what the element structure is. Here you can see that if we view it, we've got that basic one with the default example. Save this here. And I want you to look where the square brackets are in this. So you'll notice here the square brackets around the actual files themselves. If we do flatten, you'll see that the square brackets now are flat. So essentially it's flattened the list out of files. And in that case there, just stick here somewhere. Okay, so if we do flat here, and I want you to see the square brackets, in this case here, now we don't have a tuple which is made up of a value and pair of reads, we've actually got all of them reads. So what we have to do is we have to say from here, our tuple now is not 2 elements, but 3. And therefore we have to say path reads 1, and we should say path reads 2. So that's the kind of the way that you can manipulate the channels to fit what's required in terms of your process. Now, both of those are completely accurate. Both of those can be used in the complete same way. It's just a kind of syntax way that you can describe that of how to create those channels as well. Okay, let's move forward then on from the farm file pairs, and we can also have some more sophisticated ways of building channels. So far, we've just looked at kind of the basic files, basic values. There's also ones for even taking things from more complex data structures. So there is one for example, from SRA. And here you can even do queries around this. So you have to set this up because it starts to use external services. But from SRA here, you can even do a query. You could say, okay, query that against a particular SRA ID. For example, if I had from SRA and I knew this is exactly what it was using there, I could then do a view on that. This may not work because you should enter if you see in the documentation, you should enter in your API key for running this, but it kind of gives you a flavor of how it works here. So here it's showing you I should use my key. And that will then return for you here. That's actually working. So it's returning for us now a sample ID and the actual location of those in the FTP. So Nextflow links in there with these services and can do that for writing that. And this is a nice way you can have some reproducible results. You can even write in here. I think you can even write like liver or something, like a liver sample, and it will just basically do that query for you. So it's pretty cool. Another thing I want to point out, which is relatively new, but also very important, is around querying databases. So in here, I'm querying SRA, but you can query any database itself. So if I say in Nextflow SQL plugin here, this is a plugin, so it's something that we're adapting and building all the time. But there is a way to have a channel factory, and that channel factory will do a SQL query against a database, and it will return for you every row that's returned from that search will be an element in the channel. And this can be quite powerful if you have like metadata in a database that you want to query, and that metadata might be sample ID, maybe the location of those files, and you can kind of run from here. It has support for all the major SQL databases here. The way it works slightly different in the sense you have to set up the plugin and your configuration, point it to your SQL. But then once you've got that set up, you can just call that, and this should look exactly like what we've just been doing, where instead of saying from path or instead of saying from SRA, now we're writing from query, and we can write a SQL query inside this as well. You can also do that at the opposite end of the pipeline. So imagine that you've run your pipeline and you want to do an insert statement. So here you want to insert something into that. That's also possible here with this with a SQL insert. It's like placing something into a database at the end of that. So that's the kind of main things that you can do in terms of creating these channels. The real power, I guess, comes from being able to create them and then really the manipulation of them via the operators, which we'll see later on. There's a couple more exercises in there if you want to go a little bit more complicated in terms of what's possible here. So this is the from file pairs, which we've covered, the from SRA as well, and how that links in there as well. Here is an example of just showing you how that pulls together. So imagine that you had your API key here for NCPI. You wanted to define some parameter accessions. Here you would say channel from SRA, pointed at that. And the key point is that the input here must match. So this channel factory returns for us sample ID and some read files, exactly like from file pairs. And then we can use it in this way here. And again, just a basic process that we're running.